Hello.
So it's recording. Still very afflicted by holiday season, I fear. I think Malcolm prepared something.
Less than you might think.
Okay, yeah, well, but more than most.
No, kind of approximating to having asked a small question and got a small response. I think one of the things that we could start by mentioning is something that you're on the call has been playing with. It's just an idea we've been bandying around, which is, I mean, it was a delightful bit of naming, a sort of confusion. I named it Helmerizer. Neuron misheard me and came up with the name Helmraiser, which is far better. So what it does is, I think it's only a bash script at the moment, but it consumes a Helm chart and creates a Tanka library from it that can track the Helm charts through time. I don't know if you want to talk about it.
Yeah, I can show something. It's a combination of a bash script, about 100 lines, I'll just pop it on the screen. I have not merged it yet. Like, this is new. There we go. Here it is. So it's a combination of script and a libsonnet file that does some magic layover over that to do the templates. The key action is here. So we do Helm template. We put some names for the release and the namespace in, like template tags, which I got from another colleague that wrote it for a specific Helm chart. I just generalized the idea, and I output the YAML files with values and whatever. If you want, you can generate that with certain values. Hopefully, build something that is generic enough that can be used within your organization, and then you can use that to use it. So let's show a bit of the code that goes in here. So it does a few small things like groups the custom resource definitions together, so you can easily cut those out if you don't need them, and then replaces all the variables with the prefix and the config name and the namespace in a clunky way, and then configures that. So that's a function. Let's show this the library itself. Start manager. It generates this file, which makes sure that every manifest file comes into a JSON construct, which you can use. The idea is that you pull that in like this, generate it. You can configure it further with something else, and then you can use other functions to patch it up or to pull it in somewhere in your main. The idea is that this file is something that doesn't change, so the generation doesn't touch this. So this is basically your overlay that you can put to generalize the library for use somewhere else in your organization. So add namespaces, or for example, we have the CRDs that we don't want to do anything labeling on, but we want to patch the labels on all the other things. So we do that here. This can if we update the shard, we can just generate a new one with a new version for a cert manager, and this one should keep on working. The idea is that what we had cert manager like version 0.13, it's already at 16, and doing the manual conversion, like watching manifest files and using that again, that's just a lot of work. With this, we can just do it automatically. Yeah, so that's the directory tree that comes out of it. That's all I had to say about it. If you have any questions, feel free. I hope to open source this very soon. Already was talking about that with Malcolm earlier.
I think the way you described it to me, which made a lot of sense, is this is not, you would not necessarily use this as a library to generate a public-facing JSONet version of a Helm chart. It's more that you're like, because a Helm chart will contain lots of conditionals that deploy things in different ways across many different varieties of infrastructure. But for a particular organization, they may well have used this to create one that suits them. And so it's going to be an internal thing.
Mm-hmm.
So the tool, the Helmerizer tool, will be public, but any charts it creates are likely to remain private.
Or you can make them public, but make sure that you say this is a different version. Like it's not not to replace the shard, it's to make the conversion. So you can plug it into existing JSONet systems.
Are you planning to put this as part of the Tanka repository or in a tools/subdirectory or something? Or
yeah, I was thinking about putting it in the Grafana JSONet libs and the scripts there. And then because we have cert manager there and we want to update it, use it as an example too. And then generate the cert manager lib in there. People can try it out, give feedback, and see how it flows. We will also use the same library internally then. And if it gets more traction or the use gets a lot of response, we can build something like more stable than just a simple bash script. We'll see how that flows. If this covers what we want, then we don't need to iterate much further.
I think getting it out and just having people play with it and making people aware of it is already half of what you want to do. And then if it really needs to be put into a Go thing or something, you can still figure it out. But it's, in my opinion, more about getting people to use it, because it seems quite useful to me.
Mm-hmm.
I mean, it solves the specific problem. Is the cert manager library is huge, and it probably took a few days to convert it from Helm to JSONet, and then they went and updated the darn thing. So we have that particular. So it solves a very, very useful problem.
$20,000 lines of manifest. Please go and convert.
Yeah, exactly. So for another topic that I thought it might be worth or interesting to discuss, to mention, is that I did a 0.01 release on Grizzly. I don't know if everyone's heard of Grizzly yet. It's an equivalent to Tanka, but instead of writing to Tanka, to Kubernetes, it pushes to Grafana, to a Grafana instance. So we've got lots of ideas about things we can improve about it. My next one that I'm going to do is to make it so that it supports data sources and dashboards. But part of the thing is, if you imagine you have you're working on developing a mixin or something like that, that it contains a dashboard, and that dashboard gets deployed to a large environment that is or large namespace, and rendering the whole thing and diffing across your Kubernetes namespace takes a minute and a half. That makes it not a very efficient development process. So with Grizzly, you can push directly to the Grafana provisioning API. It's even got things like watch, so you can do this was all Tom Brack's idea. The GRR is the shorthand. GRR watch. It's got the same apply, show, diff syntax, but also watch will watch for file changes on disk, and when it notices one, it'll push it straight up to the API. So as soon as you save your file, your dashboard is re-rendered and pushed up to Grafana. At the moment, you'll have to reload the page, unfortunately, but still, it's likely to be much, much simpler than it was. Yeah, so I don't know if that's something that's useful. We've got lots of ideas about things we can do to improve this whole set of tooling and the way it works with Tanka and so on. They seem to sort of very much complement each other.
I'll post here the script that can be used to wrap a Grizzly watch and reload like Firefox or something with X11.
Great.
And also port forward. So if it's on Kubernetes somewhere and it's not public, then you can port forward it. Feel free to use the code in whatever way you see fit. I enjoyed it very much with the Grizzly watch. Then you can just like save and it automatically starts the upload and the reload, and you can just see it's changing while you're coding.
Personally, I see quite a lot of potential in the tool. We were thinking about modifying, like doing something on top of monitoring mixins, and I think this solves at least one part of that. We were thinking of creating something that would be like monitoring bundles, basically, which is monitoring mixin, but already rendered for your cluster, for your environment.
Yes, I've noted that specific need as well, because at the moment we have the mixin is an agnostic thing. It says here are the dashboards, here are the Prometheus rules, but then you need to also, in order to make it work, you also need to specify your data sources, maybe your notification channels, maybe you need to specify your Grafana users, blah 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 blah. But there is no standard way to specify those. And quite possibly we do it differently to you and so on. So even if we don't consider them to be a part of a mixin, having a definition as to how those should be defined in a bundle that may wrap a mixin would be extremely useful.
Yeah, that was the idea, to have the agnostic mixins and having a bundle that is kind of opinionated towards one of basically creating a package management for monitoring mixins, something like this. So you can put your definitions, your configuration into that, and generate a bundle for your environment. I see that this is like, I wonder if we can extend that to Prometheus, so it can ingest the whole thing and configure also alerts and recording rules, because that's the last part for monitoring mixin.
Can you say a bit more there? What do you mean?
Yeah, so in monitoring mixing, you have like two parts, which is the Grafana dashboard, and I think this takes care of that part. But the second part is your alerts, and a lot of monitoring mixins come with configuration options for those alerts, like excluding some jobs, excluding some labels, basically a label selectors or thresholds, and creating some sort of opinionated configuration management for those basically creates a bundle. So we were thinking previously about creating something like I think Matthias created the site that is prompt tools for SLO to generate alerts, and we were thinking about creating something like this, cross-referenced with monitoring mixin's site, which would be get data from monitoring mixin and go to a site, check your monitoring mixin and put your configuration options. And then, well, you have the YAML files and you can load those into your environment. The idea is to like have something for less advanced users, basically someone who doesn't know how to use JSONet. And I think kind of extension to Grizzly could solve this maybe. That's just a rough idea. I literally found the tool right now.
Fantastic. I mean, in terms of Prometheus, Prometheus is a difficult thing to configure because it just wants one config file, but there may be ways we can work with that. I mean, something I've been playing with for ourselves is mounting each mixin, the config files for a mixin, for each mixin into their own config map. At the moment, we put them all in one, but putting them each into one config map makes it a bit more. It gives a little bit of extra independence.
Yeah, that's the same concept I'm using in Ansible roles, to use each of the rules files as a separate file. So basically, in Kubernetes world, each mixin its own config map.
Yeah. Yeah. Great. I'll say it's open source. So if you have ideas of things it could usefully do, then absolutely feel free to come along and suggest things. And the only thing I will throw out is it is I'm not sure if there is such a term as pre-alpha. But it's very young, and and we're doing a lot of talking about this whole space. So exactly what shape we'll want it to go and where we'll want it to be and so on, who knows? But it's getting the idea out there.
I just shared the link to the Helm raiser script. It's in the PR. Still draft, so yeah, just play with it, see what it is, and we'll probably do some example like throughout the week somewhere with Cert Manager.
So I think
Wasn't
that's
Jack
probably everything.
Sorry.
I think that's probably
Jack
everything.
doing something the opposite or something?
He was looking at was he looking at helping the consumption of JSONet within Helm charts? Yes, he did, didn't he? Because he was doing he was if you take a JSON library and you export the _config object into a values file, and then replace all of your _config entries with curly, you can basically render a Helm chart from a JSON library. You lose all the if-then stuff and conditionals, but the basic idea works as well. I mean, again, that's definitely pre-alpha stuff, but the idea is there.
If you can JSONify the templating, then you have gold.
Yeah. So I think that's probably all I can think of for us to share outwards from this side. I guess we can, you know, open the floor at this point. Is there anything any questions, bugs, objections anyone wants to share?
I've been working this week on refactorings to make our internal and also some public libraries to use Tom's K8s library, which removes some like type usage and things like that. Are you guys using the new KSonnet thing from Tom?
So have either of you used the old KSonnet k.libsonnet library? Was that something that was a part of your workflow? Yeah. So basically, KSonnet was deprecated ages ago, a year and a half to 2 years ago, and then discontinued probably a year ago. So we jumped in finally and replaced KSonnet, the tool, as with Tanka. Yay, we can carry on going. But we've continued relying on the k.libsonnet library for forever since then. But it's a deprecated thing. So Tom Brack jumped in and started helping to maintain that library and managed to get some releases that were available for APIs above Kubernetes 1.8, for example, just to show how advanced it was. But he found that code base, the code base that generates the library, the JSONet library, from the Kubernetes Swagger to be too complex. So he started again, and he's now created. I'm sure Euron can post the link. Oh, he already has. There you go. He's read my mind. This library, which basically replaces that. So it gives you access to your Kubernetes resources. It's mostly a drop-in replacement for the KSonnet library. But not only does it come with you know, a slightly cleaner API, it also comes with and versions for each Kubernetes API version. It also comes with docs. So he's created a thing called DocSonnet, which if you put a certain kind of annotations in, it'll give you it'll generate documentation for you, which was always a really, really difficult, painful thing working with JSonnet before that. Certainly JSonnet and Kubernetes, and this library anyway. So it's definitely worth trying out and giving some attention to if you use the previous library. I suspect I suspect if we seem to have, you know, not too much more to discuss. I think the topic that we could continue to explore is that one of, because I know there is some commonality there is around monitoring mixins. It's the topic that we are at Grafana exploring a lot, and you know, I would appreciate hearing more how other people are using them. You know, I know you, Pavel. Are you using monitoring mixins, Kemal?
Yep.
Are you willing to say a little about how you use them?
Yeah, I meant basically at the same time with Pavel. So we are just like, I'm also maintaining Thanos mixin and upstream Thanos mixin, and we both using all of those in our stack.
Okay, great. So how do you structure the Thanos mixin? How does that compare?
Well, what do you mean actually by structure?
So you're saying you work on a Thanos mixin.
Yep.
Is that as in to monitor Thanos, or that deploys configuration in order to set up Thanos for other applications?
Thanos mixin is just for the monitoring part. We also have another project called Cube Thanos, and for that we just use that repo to deploy to basically provide deployment manifest for Kubernetes.
Right. So it's equivalent. So what sort of configurations would Thanos require on top of what we provide for Prometheus?
Like they are basically deployment scripts, nothing fancy, but just we want to define something to easily. You can just put your cluster and you can just spin off some Thanos. And yeah, they are mostly like more or less it's 4 hour stack right now what we use. Then we just like provide an option to the community.
Yeah. Okay.
Yes, for monitoring mixins, I can share some insight. There was some thought about creating a second draft for the monitoring mixins. The main issue was about global state for the mixins. And what we found out is that actually the V1 documentation and V1 reference doc for monitoring mixins doesn't state anything about global state, which means that it should be fine, and that the only problem here is that we usually basically created a bad practice of creating a global state for all monitoring mixins. And the next plan is for us to modify Kube Prometheus project, which is like one of the main consumers for a lot of monitoring mixins, to get rid of that global state and promote some better practices of using monitoring mixins and possibly creating them.
Yeah. Absolutely. So, I mean, what we went through this probably like 6-month process of complaining and moaning about global state and how horrendous it was and how disastrous and terrible, and how it was disgusting how these libraries forced us into using this global state and writing lots and lots of long documents about how we wanted to rewrite everything. And then gradually over a period of time of moaning and complaining, we actually realized that you can consume these libraries. These libraries themselves don't actually declare or define or state anything about global state. All they require is a an underscore config in their root.
Yeah, exactly.
And it took us, I think it took us quite a while to get to that simplicity. So we've been moving away from, in our library, the Prometheus K-Sonnet, moving away from each library being just added into the global root and having them in their own mix-in space. And suddenly everything gets so much cleaner. And you can do some really powerful things, in Kubernetes libraries as well, where you have a global root, but then rather than adding that, rather than just allowing a library to reach out to the global root, you pass in, you say, my library, my library, which is an import, curly bracket, _ global, a config rather, and then you import the global config for stuff that's like the cluster name and namespace, and then you add on whatever the config is you want for your environment for that particular library, and then everything is clear that this stuff configures that thing. And it's like, yes, that's what we do in programming, isn't it?
That's exactly what we plan to do in Kube Prometheus. Basically the same thing. We just hit like a major bug for one thing that basically came down to having a global state, and one library somewhere down in vendoring path overrode everything.
Yeah.
Didn't know what the hell is happening.
Yeah. Could you show that Cloud SQL PR? This is an internal bit of code, but it just showed what we worked out really well. I mean, something I'm thinking of is I'd like to at some point do sort of put something a bit more public about actually how to write. We've overused the term effective JSONet, but how to write JSONet well. How to like things like, in our current Prometheus case on it, you say add a data source. So it takes your parameters, renders it as YAML, and then adds that to a map. But now nothing else can interact with the data inside that because it's already been rendered to a YAML. Whereas if you waited later and stored it just as JSON, you could manipulate all sorts of things about that. So there's lots of things that we're learning about how to be really powerful and effective with JSONet that aren't obvious, and as far as I can see, aren't documented out in the world, and I think could really benefit the world beyond Grafana as a JSONet consumer or the Tanka ecosystem or anything. I think it'd be really useful to get some of that out there. So you're letting the code talk for itself. Oh, you're muted.
There it is. So instead of adding them to the top, have this global state and put stuff in _config, we just move it down the line and say, oh yeah, now we have a Cloud SQL top level object and we add everything what we need in there. That's it. And from there on, you can like add mixins or anything else. Like if here you have the Cloud SQL, I can. So what I want to do was actually this. I had the Cloud SQL here, and I have this import key, and I don't want that key there. I want the key to be. I don't want the secret always there. I want to use a function. So now I have a function that I add, like say with credentials, and it adds it as a mixin. And it's obvious it belongs there. And yeah, and now when we start using Vault and use Pentagon for that secret, we don't use this. We just remove this bit from the line, and the secret disappears from the JSON code, and it pulls it from the secret that is created by an external program. And it's easy to find.
So is that the sort of thing you were talking about, Pavel?
Yep, that's exactly what we plan to do in Cube Prometheus. However, it might be a bit. It will be quite an endeavor to do it in Cube Prometheus because it organically grew into something that is quite large and covers a lot of edge cases.
Yeah.
Yeah, this is also the nice thing about this. We can do it gradually, so we just move one bit at a time. Like now, I just did the Cloud SQL one because it crossed my path and needs some small refactoring for using it with Vault. And yeah, then you do that and you ignore all the rest because it still works. It can still stay in, everything can stay in the root scope until you need to change that. So it's very agile.
Yeah, the problem for us is that the main consumer from our side is cluster monitoring operator. This is the main consumer for Cube Prometheus, which is both are having a lot of JSON-net code. So everything that we change in Cube Prometheus, we need to carefully port into cluster monitoring operator, and that's why this will be quite an endeavor to actually mutate that. Because we will be doing probably that with carefully going through each of the components and immediately porting that into OpenShift for those components. So it will be a quite slow process probably.
The biggest fear we actually have, our biggest worry, is that other libraries reach deep into the code and try to get configurations that are in other libraries because they can, because they are in the root scope. This is prevents that, and for the better. So
yeah, I can see that it's much cleaner to figure out what is actually going on.
Absolutely. So I'm curious, how much? So you're doing this work, and how much? To what extent do you? Is this something that you use JSON-net internally? Or is it something that your customers use as well? Your customers find themselves using JSON-net as well, or is it just something you use internally to maintain stuff?
No, we are all in on operators. So basically what we are using JSON-net for is to create YAML manifests and bake them into Golang binary. This is what we deploy to customers, which is the immutable stack for monitoring. And basically what we use JSON-net for is to get all those mixins and Cube Prometheus, Cube Thanos projects into one repository, mangle them up, and create YAML files which we are satisfied with, bake them into Golang, and ship as a container. The thing that we are baking into Golang probably will change soon because we have like baking that amount of YAML and using bin data for that causes some problems with merge conflicts. So we are in process of changing this thing. But yeah, but we are using JSON-net only for us, basically, for dependency management. And since this project is using now Prometheus mixin, node exporter mixin, Cube Prometheus, Prometheus operator CRDs are also in JSON-net, Kubernetes mixin, I have no idea, maybe probably some even more, and it's all in one.
Okay, interesting. So this is very much a project that just that the whole mixin idea for you is something that is it's a scratch your own itch thing. It's a thing that makes life easier for you to do your job.
Yeah. I wouldn't say that it's easier, but
In addition to that, like we are kind of like a sister team to Pavel's team. We built an operator that also like just deploys to JSON at manifest. Like we are just experimenting that idea. That is using a tool from Frederick. So yeah, that's also a kind of we are kind of using under the hood, and we are planning to provide this functionality to our customers as well.
Okay, interesting.
Cool.
Thank you. I appreciate hearing that take on what you do. I mean, what do you make of what you hear of us at Grafana talking about? Do you feel like, you know, from what you've been hearing and so on, that we're heading down the same track as you? Do you feel like it's, you know, would it be useful to have more venues? I don't know what I mean by a venue, but places to talk about these things.
What do you
know,
mean?
in terms of defining monitoring mixin version 2. You know, is that something you know, you say you're actively, are you actively talking about mixin version 2, or is it something you just talk about every so often when you think you really?
No, we literally just like today kind of scrapped the idea because well, for version 2, you need something to change, and most points that we wanted to change, we figured that, well, those don't need to change because those are already covered, and this is only our use case that was wrong. So I don't think there is much to change and to create V2. So V1 is probably fine. What we found, at least what I found, is that we have quite a lot of things that are very fluid in monitoring mixin space. For example, we have quite a lot, since we are ingesting quite a lot of those mixins. We found some issues, for example, between Prometheus mixin and Kubernetes mixin, which are defining different annotations for alerts. This is not something that is very important, but it's scratching some customers. It's like, well, why do you have annotation which in this annotations you have a summary and description, and here you have message? How do I create my alerting rule and alert manager configuration if you have both? And those are the things that we probably want to tackle to define those parts of the spec to be like more consistent and to provide some better readability. Maybe I know that right now we have few fields that are very fluid, and you basically can define what you want. I know that, for example, Ceph mixin defines quite a lot of annotations, and they mix and match basically everything, and it doesn't provide much value to customers. So personally, I would like to like settle on something there. But yeah.
Yeah. Are your mixins themselves, what percentage of the mixins that you consume are private and which percentage are open source? Are you willing to, you know, do you use much? You don't have to sound that. I'm just curious.
It's actually easy. 0% is private, 100% is open source.
Okay, great. Do you have a place where they're visible?
Yes, it's called, yes, I can link it. Give me a second. everything is here.
Okay. Thank you. I'll have a dig around there.
Now the C OpenShift. I have seen 2 issues come on the Tanka repository, people reporting on something that happens on OKD where they only have access to like one namespace and get like, because we do list namespaces, it fails. We are not like used to that, and we don't know what to do with it. Also, we don't have OpenShift Kubernetes access somewhere to test this. Currently, we intend to leave it a bit open for the community to have a look at that and maybe pick it up as a development thing.
Yeah, so it might be strange because our monitoring stack in OpenShift till version 4.6, which I don't think it's released even yet, is completely immutable. So if you want to monitor your own application, you need to go through some tricks to do that. And we prevent using the in-cluster monitoring stack for this. That's why you might have various reports about OpenShift strange issues with Prometheus or Grafana.
Yeah. Here's one of the issues. I find that interesting. It's probably something we can do different there. Feedback from people that work closer on it would be great.
Oh yeah, this is actually fairly simple. It's basically an RBAC issue. So the kube config that is ingested into Tanka is insufficient to do this, basically. I don't think you have like, yeah, in case of OpenShift, you cannot list all namespaces because namespace in OpenShift from the point of usual user is identical to a project, and this is a tenant isolation. It's a soft tenancy model for OpenShift. So if you don't have enough permissions, you need admin permissions for that, actually. You basically cannot list all namespaces, and that's why it fails.
Yeah,
So
figured it was something like that.
So what would you suggest as an appropriate fix?
Let me take a look. Yeah, debugging in real time.
Absolutely.
We're engineers, right?
Yeah, so treating that as a soft failure might be a workaround for this, since if you cannot list all namespaces, maybe just limiting the options for the diff, and possibly providing an option to like specify namespace to the TK binary to the diff. So we can use this namespace and not do a list from the cluster. Because you actually either this or I have no idea if in our kubeconfig, we specify that somewhere what is the RBAC policy, what is allowed for namespaces. This is something I would need to check. But basically, in this case, you need to somehow figure out what is the namespace before doing the diff. Otherwise, you cannot. Otherwise, the airbag policies in OpenShift won't allow this. So it's either specifying that namespace and passing that to TK binary, or going through some chain of configuration options and parsing kubeconfig to figure out what is your actual namespace that you're using right now as this user. The second part is obviously better for user from user perspective. First part is much simpler to implement.
Okay.
And what was the second issue that you said you have?
Let me have a quick look. It probably uses the same function. Yes, it's when it wants to prune, so it's the same problem. I'm pretty sure. When I look at, I haven't looked into this one. It's like from yesterday. Or, no, it's from this morning. So
Yeah, I can already see that it's the same. This is also hitting the tenancy model in OpenShift.
Yeah, I think the call indeed happens because it wants to check if the namespace exists, so it just pulls all namespaces, and then if it doesn't exist, it makes sure it can be created, and it does some ordering of the diff and things like that. So that's why we required in Tanka. So it'd be interesting to work around it.
And I don't think you can have an airbag policy. Like, I don't think you can actually ask for the namespace in OpenShift when you are just a user, unprivileged user. Because as far as I know, the only way to check namespaces is to list them all. There's no check to like pass the namespace and get the response that yes, this exists or this doesn't, because this will obviously this will be also against the tenancy model, because you can actually get the information if that exists.
Yeah. Right. Thank you. That was very useful. It was until now some guessing for us. It's like, yeah, it's probably stuck somewhere there. So now we have internal information. So awesome. Feel free to submit a PR.
I suspect, unless anyone's got any other things to raise, I suspect not. Yeah. Well,
No.
Thank you very much. It was it's great to meet you both.
Yeah.
And to to hear more about what the stuff it's like I've known sort of from a distance of the stuff you're doing, and it's good to hear in a bit more detail. And
Sure.
see where it meshes and see where it's different and so on. That's very, very useful. So good to meet you.
Yep.
Yeah. Always feel free to reach out on the Grafana or the Kubernetes Slacks.
Absolutely, likewise.
Yep.
Good.
You can reach out to us too.
All right.
Good. Thanks a lot.
Speak
All right,
soon.
see you later.
Bye.
See you.
Bye.
Yeah.